In this lesson, we discuss conditional probability. All right, we begin with our definition for conditional probability. The probability of event E sub 2, like a second event, occurring given that a first event called E sub 1 has happened or will happen for sure. The time relationship doesn't matter whether it has happened already or if we know for sure it will happen. It's called a conditional probability, and this is how we write it. The probability of E sub 2 happening given that E sub 1 has happened or will happen. For example, imagine one card is drawn from a standard 52 card deck. Determine the probability that the card drawn is, let's do the first one, a king. All right, first of all, there are 52 cards in the deck, and out of the 52 cards, there are 4 kings, right? There's a king of spades, a king of clubs, a king of diamonds, a king of hearts. So the probability of us choosing a king, right, is 4 out of 52, which is 1 over 13 when we simplify that. So that's the probability of us choosing a king. Now, for the second question, this is conditional probability. We are being asked to determine the probability that the card is a king given that first the card is a face card. Okay? All right, since we know the card is a face card, we no longer consider all 52 cards as possible outcomes. Okay? Instead, we only consider the 12 face cards as possible outcomes. Of these 12 face cards, 4 of them are kings. All right? So this is what we do. The probability of us choosing a king, assuming that this has happened. We have to assume that this has happened, that we have a face card. Okay? Look back at the definition. Given that the first event has happened, so we have to assume that we are only considering face cards. All right? That means this probability is equal to, the second one here, is there are 4 kings out of 12 face cards. Those are the only possible outcomes. All right? So then this is 1/3. That's the answer for the second one. Okay? Let's look at the next one. What is the probability that we choose a diamond? How many diamonds are there? Well, there's a complete suit of diamonds, right? So remember, in a standard 52 card deck, there are the numbers 1 through 10, the number 1 being the ace, and then your jack, queen, and king. So there's 13 spades, there's 13 clubs, there's 13 hearts, there's 13 diamonds. So therefore, this probability that we choose a diamond is 13 out of 52. So a quarter, 25%, is the probability that we'll choose a diamond. Now, what's the probability that we choose a diamond given that the card is a red card? Again, this is conditional probability, so we have to assume this has occurred or that it will occur. All right, so now we no longer consider all 52 cards as possible outcomes. Instead, we only consider the red cards as possible outcomes. Now, how many of the 52 cards are red? Exactly half, right? You have all the diamonds and all of the hearts are red. That's half the deck. So this probability that we choose a diamond, given that this has occurred, a red card has occurred or will occur, is equal to 13 diamonds not out of 52, out of 26 possible outcomes for red cards. So then this is 1/2. Our next example says a family has two children. Assuming that boys and girls are equally likely, determine the probability that the family has two girls. Okay, so, and then of course there's part B and C, but let's just focus on part A right now. To determine the probability that the family has two girls, let's use a tree diagram to determine the probability that both are girls, that both children are girls. All right, tree diagram. Let's do it. All right, so for this first column right here of our tree diagram represents the first child. So if they had a boy, right, for the first child, for the second child, they could have another boy or they could have a girl at that point. So the sample points in the sample space, this is your sample space here. The first two sample points are boy, 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 girl. Now, for the other option, if they had a girl first, after that they can have the boy as the second child or another girl, right? So the sample points are girl, boy, and then girl, girl. So there are 4 sample points, and they're all equally likely outcomes. Okay, only one of the outcomes has 2 girls. Therefore, the probability, this is the answer for part A, the probability that they will have 2 girls is 1 out of 4 equally likely outcomes. Now, let's go to conditional probability. Part B. What's the probability that the family has 2 girls given that at least one of the children is a girl? We are given that at least one of the children is a girl. Therefore, for this example, the sample space is, let me erase what I've circled here. Let me erase the answer for part A, okay? I hope you all have that. For part B, it says, given that one of the children is a girl. Look at the sample space. Notice that there are only 3 options, possible outcomes for one of the children being a girl. Okay? So for part B, this probability, this is how we would write it. The probability of both of the children being girls, given that at least one is a girl. Out of these 3 options, only one, right, is girl, girl, right? So 1 out of 3 options. Okay? So you don't consider all 4 possible outcomes. You only consider the 3 possible outcomes where at least one is a girl. All right? Okay, next. What is the probability that the family has 2 girls given that the older child is a girl? That means they had a girl first. Okay, let me erase what I've done here. I hope you all have that. All right. Cool. All right, here we go. So the probability of both of them being girls, given that the older child is a girl. Look at your sample space. There are only 2 options, possible outcomes where the first child, the older child, is a girl. So that means our denominator in this probability, let me move this equal sign over here a little bit. So the denominator will be 2. There's 2 possible outcomes, right? And only one of them is the one where they're both girls. All right. Now, we have a formula, of course, for conditional probability. All right, so let me give it to you now. That'll help us with future problems. Now, I must say that there are other formulas that can be used to determine conditional probabilities, but this is the one that you and I will use. All right, the probability that event number 2, right, E sub 2, will happen, given that E sub 1, this first event, has happened or will happen, is equal to the cardinal number of E sub 1 and E sub 2, okay? Remember the cardinal number back in earlier studies, divided by the cardinal number of E sub 1, okay? In this formula, the numerator represents the number of sample points that are common to both event 1 and event 2. The denominator is the number of sample points in the first event. Okay. So we can actually write the formula like this. I kind of prefer it written this way, by the way. The number of sample points in this set, instead of the word and, use the intersection symbol, you know? This is how I will write it instead of using the word and, okay? All right, cool. All right, so we have 250 patients who had either knee, hip, or heart surgery. They were all asked whether they were satisfied or dissatisfied regarding the results of their surgery. And here are their responses. Okay, so let's go over this table really quickly. So you had knee surgery, 75 of them were satisfied, 20 were dissatisfied. A total of 95 people had knee surgery. 95 includes all the satisfied and dissatisfied patients. For hip surgery, 90 of the 250, right? 90 were satisfied, 15 were not. 105 total people had hip surgery. Heart surgery, 45 satisfied, 5 dissatisfied, 50 total patients had heart surgery. So when you add up all of the satisfied surgery patients, 210 total out of 250 patients, 210 of them are satisfied with their surgery. 40 out of 250, 40 are dissatisfied. And so when you add up all the satisfied and dissatisfied patients, you get the total population of 250 patients. All right, here we go. If one person is randomly selected, determine the probability that this person was satisfied with the results of the surgery. All right, this one is really straightforward. This is not a conditional probability. So you have a total of 210 patients that are satisfied, right, with their surgery out of 250 total patients. Simplify this by dividing by 10. So you get 21 over 25. This is the probability that that one randomly selected patient is going to be satisfied with their surgery. Now, the rest of these, parts B, C, and D, are conditional probabilities. And I'm going to have to use this formula up here. Okay? All right, here we go. What's the probability that the patient is satisfied with the results of the surgery given that the person had knee surgery? Okay, so we are given, the part that we are given, right, is that the person had knee surgery. Okay, this is that the person had knee surgery. So this is definitely a conditional probability problem, okay? So I'm going to let E sub 1 be the event that the person had knee surgery, okay? This is the given information. This is the given. Remember, back up here with conditional probability, it's the probability that this event E sub 2 will happen given E sub 1. So E sub 1 represents the given event. And here, the given event is right here, given that the person had knee surgery. So E sub 1 represents the given. E sub 2 represents the event that the person chosen randomly is satisfied with the results. So we are asked to find the probability that E sub 2 is going to happen given that E sub 1 has happened or will happen. What's the probability that the person selected at random is satisfied with the results of the surgery given that they had knee surgery? All right? All right, let's use our formula for this probability. The numerator is the number of sample points, or the cardinal number of E sub 1 intersection E sub 2, right? All of the patients that are in both of these sets. All right, so let's look at our table. How many people had knee surgery and are satisfied, right? So let's look at the table. We have a total of 95 people that had knee surgery, right? We have a total of 210 people that are satisfied. But we need to find the number of people that are in both of those sets. You can't just be satisfied with your surgery. You have to have had knee surgery. You can't just have knee surgery, but you have to have been satisfied. So don't look at this number and don't look at this number. Look at this number. This is the number of people that are both satisfied and had knee surgery. 75 people had both knee surgery and are satisfied. So that's the numerator. Now the denominator, I'm looking at my formula. How many people, right? How many sample points, right? Or I'll just say patients. How many patients are E sub 1 stands for knee surgery. How many people had knee surgery? Look at your table. 95. So it's 95. Simplify by dividing by 5. You get 15 over 105. Oh, you know what? No, you don't. You get 15 over 19. This is that probability. All right, let's go for the next one. We want to know what's the probability that the person selected at random is dissatisfied with the results of the surgery given that the person had hip surgery. All right, let me edit what I've written down. So let me edit this, okay? So make sure you have this written down before it goes away. All right, so let me edit this. I'm going to make E sub 1 my given, which in part C, the given is that the person had hip surgery. So let me just change this word to hip. And then the probability of the second event happening is going to be dissatisfied. All right, I think I got it. All right, so here we go. Conditional probability that the second event will happen given that the first event has occurred or will happen. All right, so keep in mind the given part is that this patient had hip surgery, and we're trying to figure out the probability that the person is dissatisfied. All right, so here's the formula. We're looking for all of the people that are in both sets. In other words, we're looking at this table, find the total number of patients that both had hip surgery and were dissatisfied. All right, hip surgery, dissatisfied, 15. So that's 15 in the numerator. All right, over the total number of people in this event. This E sub 1 event for us is total number of people that had hip surgery. So hip surgery, total number 105. So then this is 105. This simplifies to 1/7. Isn't that great? All right, let's go to the last one, folks. The last one is the probability that the person selected at random had heart surgery given that the person was dissatisfied. All right, so let me change E sub 1, the given part, to dissatisfied. And E sub 2 is going to be heart surgery. All right, here we go. So in the numerator, we need to know all of the patients that both are dissatisfied and had heart surgery. Okay, that would be right here, this number, which is 5. 5 patients had heart surgery and were dissatisfied over the total number of patients that are dissatisfied. So dissatisfied, total number of patients, 40. So it's 5 over 40, which of course simplifies to 1/8. This is conditional probability.